February 14, 1943, Henderson Field, Guadalcanal. VMF 124 launches 12 F4U-1 Corsairs into tropical air thick with humidity and promise. Major William Gise leads the bent-wing fighters northwest toward Bougainville. Their Pratt and Whitney are 2800 double Wasp engines producing 2,000 horsepower each. The mission: escort Navy PB4Y Liberators against Japanese positions at Kahili airfield. The mechanism is revolution wrapped in aluminum and steel. The U.S. Navy and Marine Corps' first operational fighter capable of exceeding 400 miles per hour in level flight. The stakes penetrate beyond tactical success to fundamental air superiority if these new Corsairs can exploit their devastating speed advantage against the nimble but slower Mitsubishi A6M Zeros. They will shift the balance of Pacific air power permanently in America's favor. A veteran Japanese flight leader banked his A6M into a shallow climbing turn at 15,000 feet above Kahili airfield. Leading a formation of 18 Imperial Navy fighters scrambled to intercept the approaching American bomber formation. The morning was clear with scattered cumulus clouds providing cover opportunities, and he expected another routine engagement against the familiar mixture of P-38 Lightnings, P-40 Warhawks, and stubby F-4F Wildcats that had been contesting Solomon's airspace for months. Intelligence reports mentioned new American fighters operating from Henderson Field, but no details had filtered down to squadron level about their capabilities or characteristics. What he and his pilots were about to encounter would fundamentally challenge Japanese assumptions about American aircraft performance and tactical doctrine. The Mitsubishi A6M Zero had dominated Pacific skies since Pearl Harbor through superior maneuverability, exceptional range, and climb performance that allowed Japanese pilots to dictate engagement terms against heavier American fighters. The A6M-3 variant in use over Bougainville could achieve roughly 335 miles per hour near 20,000 feet, while maintaining the legendary agility that made it nearly impossible to outmaneuver in horizontal combat. Its Nakajima NK-1F Sakai 21 radial engine produced about 1,130 horsepower, driving the lightweight fighter to a service ceiling on the order of 34,500 feet with a climb rate around 3,100 feet per minute. These performance characteristics had enabled Japanese pilots to maintain tactical superiority despite being outnumbered, using energy management and superior climbing ability to engage or disengage at will. Major Gise's Corsairs approached Bougainville at 22,000 feet, their altitude advantage providing both tactical flexibility and optimal performance for the F4U's supercharged engine. The Pratt and Whitney are 2,808 power plant delivered maximum power at high altitude through a mechanically driven two-stage supercharger that maintained engine performance well above the operational ceiling of most enemy fighters. At 20,000 feet, the F4U-1 could sustain about 405 miles per hour while retaining excellent control authority and structural integrity. More significantly, the Corsair's power-to-weight ratio enabled climb rates exceeding 2,900 feet per minute, allowing pilots to maintain energy advantage through vertical maneuvering that Japanese fighters could not match. The engineering philosophy behind the F4U Corsair represented a fundamental departure from previous American fighter design priorities. Where earlier aircraft like the F4F Wildcat emphasized ruggedness and defensive firepower, the Corsair was conceived specifically to achieve maximum speed and climb performance. Chief Engineer Rex Beisel had prioritized power over weight, creating an aircraft that could outrun and outclimb any existing fighter while maintaining sufficient structural strength to withstand high-speed maneuvering loads. The distinctive inverted gull wing design solved the engineering challenge of accommodating a massive 13-foot propeller while maintaining ground clearance and optimal aerodynamic flow. The Japanese leader first spotted the American formation at 1,347 hours as dark specks against the western sky. Their altitude estimated at 20,000 feet based on perspective and cloud shadows. The bombers appeared to be the familiar B-24 Liberators, but the escort fighters presented unfamiliar silhouettes that did not match intelligence profiles for known American aircraft types. The bent wing configuration was distinctive, creating a profile unlike the angular P-38 Lightning or stubby F4F Wildcat. More concerning was the formation's apparent speed, which seemed excessive for American fighters previously encountered over the Solomons. Standard Japanese intercept doctrine called for climbing attacks from below and behind, using the Zero's superior rate of climb to achieve firing position before enemy fighters could respond. The tactical challenge facing Japanese pilots was compounded by fuel considerations that limited engagement time and maneuvering options. The flight from Rabaul to Bougainville consumed approximately 40% of available fuel, leaving sufficient reserves for 20 minutes of combat before mandatory return to base. This constraint required Japanese pilots to achieve quick victories through superior positioning and marksmanship, avoiding prolonged engagements that would exhaust fuel supplies. The Zero's exceptional range had been purchased through weight reduction measures that included minimal armor protection and self-sealing fuel tanks, making the aircraft vulnerable to defensive fire while limiting tactical options during extended combat. Major Gise observed the approaching Japanese fighters through his canopy, counting 18 single-engine aircraft in loose formation climbing toward the bomber stream. Intelligence briefings had emphasized the Zero's turning ability and climb performance, but tactical doctrine developed during Corsair training emphasized speed and altitude advantages that could negate Japanese maneuvering superiority. The recommended engagement technique was simple: maintain altitude advantage, use superior speed to control engagement timing, and avoid horizontal turning contests where the Zero's agility provided tactical advantage. The 650 caliber M2 Browning machine guns mounted in the Corsair's wings carried about 2,300 rounds of armor-piercing incendiary ammunition, sufficient for sustained combat operations. The engagement commenced at 1,351 hours when the Japanese formation reached 18,000 feet and initiated attacks against the bomber formation. Japanese tactics called for coordinated passes against the bombers while maintaining formation integrity to defend against escort fighters. But the appearance of 12 Corsairs diving from 22,000 feet disrupted standard procedures. The American fighters approached at speeds that appeared impossible based on previous combat experience, their steep diving attacks achieving closure rates that prevented effective defensive maneuvering. The Japanese leader estimated the attacking fighters were traveling at least 450 miles per hour in their initial dive, a speed that exceeded the maximum level flight capability of any fighter previously encountered. The lead section of VMF-124 drove into their attack, targeting the trailing elements of the Japanese formation with a high-speed pass that demonstrated the F4U's primary tactical advantage. Diving from 22,000 feet at an angle that maximized speed while maintaining control authority, the Corsairs accelerated to near 470 miles per hour before opening fire at 400 yards range. The armor-piercing incendiary rounds from 650 caliber machine guns converged on a Zero that was climbing to intercept the bombers, the heavy bullets shredding the lightweight fighter structure and igniting its unprotected fuel system. The Zero disintegrated in an orange fireball that scattered debris across a quarter-mile radius. The speed differential between attacking Corsairs and defending Zeros created tactical conditions that Japanese pilots had never previously encountered. Where earlier American fighters could be intercepted during their attack runs through superior Japanese climb performance, the Corsairs completed their passes and climbed back to altitude before defensive maneuvers could bring guns to bear. The F4U's speed advantage translated directly into tactical initiative, allowing American pilots to choose engagement timing while remaining beyond the reach of effective counterattack. Japanese pilots attempting to pursue climbing Corsairs found their aircraft rapidly falling behind, their engines unable to maintain power at the high altitudes where the supercharged American fighters operated most effectively. A wingman in the Japanese formation attempted to turn into the attacking Corsairs but found his aircraft outmatched in every performance parameter except horizontal turning radius. The American fighters maintained their speed advantage through vertical maneuvering that exploited the F4U's superior power-to-weight ratio, climbing away from combat at angles that the Zero could not match. Attempts to follow the retreating Corsairs resulted in stalls near 20,000 feet, aircraft shuddering on the edge of control as their Nakajima engines struggled to maintain power in the thin air. By the time they recovered, the American fighters had regained altitude and were positioning for another attack. The psychological impact on Japanese pilots was immediate and profound. For 18 months, the Zero's performance superiority had provided psychological confidence that enabled aggressive tactics and successful outcomes against numerically superior American forces. The sudden appearance of American fighters that could outrun, outclimb, and outgun the legendary Zero created cognitive dissonance that challenged fundamental assumptions about relative combat capabilities. Pilots who had previously engaged American fighters with confidence now faced opponents that could control engagement parameters while remaining invulnerable to conventional intercept tactics. The Japanese leader recognized the tactical impossibility of his situation as 3 more Zeros fell to Corsair attacks, while his formation remained unable to achieve effective firing positions against the American fighters. The Corsairs' speed advantage enabled them to attack from multiple vectors simultaneously while maintaining sufficient energy for escape after each pass. Japanese radio discipline began breaking down as individual pilots called for assistance or reported ammunition expenditure without visible results against targets that refused to remain within effective firing range. The formation integrity that had been the foundation of Japanese tactical success was dissolving under pressure from enemies that could not be engaged through conventional means. Major Gise's tactical coordination demonstrated the effectiveness of American training doctrine that emphasized coordinated attacks by multiple sections operating at different altitudes. While one section engaged the Japanese fighters directly, a second section struck at any Zeros that attempted to reach the bomber formation. This layered defense prevented Japanese pilots from achieving their primary mission, while simultaneously exposing them to continuous attack from American fighters that could maintain altitude and speed advantages throughout the engagement. The bomber formation pressed to its target under heavy pressure, striking Kahili even as losses mounted in the fierce air battle. The engineering advantages that enabled Corsair superiority extended beyond engine power to include structural design features that allowed sustained high-speed operations. The F4U's fuselage was constructed using advanced aluminum alloy techniques that provided strength to weight ratios superior to contemporary designs, while the wing structure incorporated innovations that maintained aerodynamic efficiency across a wide speed range. Control surfaces remained effective at speeds that would have caused structural failure or flutter in earlier aircraft, enabling pilots to maintain precise maneuvering capability during high-speed combat. These technical advantages translated directly into tactical capabilities that Japanese aircraft could not match. The armament differential between Corsairs and Zeros represented another dimension of American technological superiority that became apparent during the engagement. The F4U's 650 caliber machine guns delivered projectiles with significantly greater kinetic energy than the Zero's mixture of 77 mm machine guns and 20 mm cannon, while the armor-piercing incendiary ammunition could penetrate and ignite enemy aircraft at ranges where Japanese weapons were less effective. More critically, the Corsairs' robust structure and armored cockpit enabled pilots to press attacks home against defensive fire that would have deterred or destroyed lighter aircraft. This survivability advantage allowed American pilots to achieve firing solutions that Japanese pilots could not risk attempting. Another Japanese section, arriving from Rabaul at 1,358 hours, found the formation scattered and under continuous attack from American fighters that seemed to operate with impunity. They attempted to intercept a pair of Corsairs that were climbing away from a successful attack, but the American fighters maintained their escape heading while continuing to climb at rates that the Zeros could not match. To the arriving pilots, The Corsairs appeared to be climbing at far more than 3,000 feet per minute while maintaining forward speed above 300 miles per hour, performance parameters that exceeded Japanese fighter capabilities by margins that made intercept attempts futile. The tactical doctrine that had served Japanese pilots effectively against earlier American fighters proved counterproductive against Corsairs that could exploit vertical maneuvering to maintain energy advantage. Standard Zero tactics emphasized horizontal turning engagements where superior agility could force American fighters into disadvantageous positions, but the Corsairs refused to engage in horizontal combat. Instead, American pilots used altitude and speed to control engagement geometry, attacking only when conditions favored quick success and immediate escape. This tactical approach neutralized Japanese advantages while maximizing American strengths, creating combat conditions that favored the technologically superior aircraft. The fuel considerations that constrained Japanese operations became critical as the engagement extended beyond normal time limits without achieving tactical objectives. The Japanese leader calculated that his formation had sufficient fuel for 10 additional minutes of combat before mandatory return to base, but the Corsairs showed no signs of easing pressure. The American fighters managed their fuel carefully, maintaining high energy states throughout the engagement while continuing to climb and maneuver at maximum performance when needed. This reflected both larger fuel reserves available from external tanks and efficient engine operation that enabled sustained combat operations without crippling range penalties. One Japanese pilot attempted a head-on attack against a Corsair that was diving toward his position, hoping to exploit the few seconds when the American fighter could not maneuver effectively. The closure rate exceeded 600 miles per hour as both aircraft approached firing range, but the Corsair's pilot maintained his dive angle while opening fire at long range. The concentration of .50 caliber fire from 6 machine guns created a cone of destruction that no aircraft could survive, while the F4U's armored construction protected its pilot from the Zero's defensive fire. The attacking Zero exploded in midair as armor-piercing rounds ignited its fuel system, the pilot having no opportunity to escape the high-speed engagement. The combat statistics emerging from the engagement revealed the extent of Japanese tactical failure against technologically superior opponents. In minutes of violent combat, several Zeros were downed, while the Americans also paid a price escorting fighters, and their PB4Ys took losses even as the bombers hit Kahili and withdrew under pressure. More significantly, the engagement demonstrated that Japanese aircraft and tactics that had dominated Pacific air combat for 18 months were obsolete when confronted with American fighters that could exploit technological advantages through superior performance and tactical coordination. The surviving Japanese fighters left the combat area shortly after 1400 hours, reduced in number and unable to achieve tactical objectives. The psychological impact of the defeat was as significant as the material losses, challenging assumptions about Japanese air superiority that had been the foundation of Pacific strategy. The American fighters had demonstrated performance capabilities that rendered existing Japanese aircraft and tactics ineffective, while the coordination and aggressiveness of the Corsair pilots suggested that American training and doctrine had evolved beyond previous standards. The implications extended beyond individual combat to strategic questions about Japanese ability to contest American air operations. The technical analysis of Corsair performance capabilities revealed the extent of American engineering advances that had been achieved while Japanese aircraft development remained static. The F4U's maximum speed of roughly 405 miles per hour represented a decisive advantage on the order of 50 to 70 miles per hour over common Zero models at combat altitudes, while climb performance exceeded Japanese capabilities by margins that made energy warfare tactics decisive. More critically, the Corsair's service ceiling of about 36,900 feet enabled operations at altitudes where Japanese fighters suffered performance degradation, creating sanctuary areas where American aircraft could operate without effective interference. These performance advantages were not incremental improvements but revolutionary capabilities that changed the fundamental nature of air combat. Staff officers directing air operations from Rabaul received initial reports of the engagement with growing concern about the implications for Japanese air strategy. The systematic destruction of experienced pilots by unknown American fighters suggested that technological balance had shifted decisively in favor of American forces. More troubling was evidence that American pilots were employing coordinated tactics that maximized the performance advantages of their superior aircraft, indicating that technological superiority was being multiplied by tactical competence. The combination of better aircraft and better tactics created a multiplicative effect that threatened Japanese ability to contest air superiority over critical operational areas. The strategic implications of Corsair superiority extended beyond individual engagements to fundamental questions about Japanese defensive strategy for the remaining Pacific territories. If American fighters could achieve local air superiority through technological and tactical advantages, Japanese ground forces would lose air support while facing unrestricted American air attacks. The interdiction of supply lines and naval forces would become routine rather than exceptional, while amphibious landings could proceed with minimal air interference. The balance of forces that had enabled Japanese defensive success was shifting toward American advantage through capabilities that Japanese industry could not match. The industrial factors underlying American aircraft superiority reflected productive capabilities that Japanese planners had consistently underestimated. The United States was producing thousands of fighters per month during 1943, with quality improvements that increased performance while maintaining production rates. Pilot training programs were graduating aviators in the thousands monthly, providing replacement personnel for combat units while maintaining training cadres. These production capabilities enabled the United States to replace combat losses while expanding total force size, creating numerical advantages that multiplied technological superiority. Major Gise's post-mission debriefing revealed the effectiveness of Corsair performance advantages when properly exploited through coordinated tactics. The F4U's speed and climb capabilities had enabled his squadron to control engagement timing while remaining beyond the reach of effective counterattack, achieving tactical objectives despite the intensity of Japanese opposition. More significantly, the engagement demonstrated that American pilots could achieve victory through technological and tactical superiority rather than individual heroics, suggesting that systematic advantages would produce consistent results across multiple engagements. The implications for Japanese air strategy were profound, challenging fundamental assumptions about relative combat capabilities. The maintenance and logistics advantages that supported American fighter operations represented another dimension of technological superiority that Japanese forces could not match. Corsair engines operated reliably with robust maintenance intervals, while sophisticated supply systems ensured availability of replacement parts and ammunition. Ground crews were trained to conduct complex repairs using standardized procedures and equipment, maintaining high readiness rates even under field conditions. These support capabilities enabled sustained operations that exhausted Japanese resources while maintaining American combat effectiveness. The psychological impact on Japanese pilots extended beyond individual demoralization to systemic effects that degraded overall combat effectiveness. Pilots who survived encounters with Corsairs reported aircraft capabilities that challenged existing training doctrine and tactical procedures, creating uncertainty about proper responses to American fighter attacks. The confidence that had enabled aggressive tactics and successful outcomes was being eroded by repeated encounters with superior opponents, while replacement pilots lacked the experience to compensate for technological disadvantages through superior skill. The degradation of pilot quality compounded equipment shortcomings, creating a downward spiral that threatened Japanese air power. Analysis of wreckage and pilot reports revealed the extent of American technological advances that had been achieved without Japanese knowledge. The F4U's engine technology incorporated manufacturing techniques and metallurgy that Japanese industry could not duplicate, while avionics and armament systems exceeded existing Japanese capabilities. Most significantly, the integration of these technologies into a coherent weapons system demonstrated American engineering competence that had been consistently underestimated by Japanese planners. The technological gap was not only substantial but appeared to be widening as American industrial capacity accelerated development programs. The training philosophy that produced effective Corsair pilots represented a systematic approach to pilot development that Japanese programs could not match due to resource limitations. American pilots averaged more than 300 hours of flight training before entering combat, including extensive instruction in gunnery, formation flying, and tactical coordination. Combat veterans rotated home to training commands, ensuring that accumulated experience was transmitted to replacement personnel. This systematic approach created uniform capabilities and tactical understanding that enabled complex operations while maintaining high effectiveness standards. The doctrinal innovations that enabled effective Corsair employment reflected American willingness to adapt tactics to exploit technological advantages rather than maintaining traditional approaches. The emphasis on speed and altitude as primary tactical weapons represented a fundamental departure from earlier American fighter doctrine that had emphasized defensive firepower and structural strength. This tactical evolution demonstrated institutional learning capabilities that enabled rapid adaptation to changing combat conditions while maximizing the effectiveness of superior equipment. The surviving Japanese flight leader returned to Rabaul with the sobering knowledge that Japanese air superiority in the Solomons had been decisively challenged by American fighters that could not be engaged through conventional tactics. The aircraft that made it back from the 18-plane formation represented acceptable losses by previous standards, but the complete tactical failure to achieve any objectives suggested that fundamental changes in combat conditions had occurred. More troubling was the recognition that the Corsairs had operated with apparent impunity, suggesting that future encounters would produce similar results unless Japanese capabilities could be dramatically improved. The engineering challenges facing Japanese aircraft development reflected industrial limitations that could not be overcome through design innovations alone. The Nakajima and Mitsubishi companies lacked access to advanced metallurgy and manufacturing techniques that enabled American engine performance, while fuel quality and availability constrained operational capabilities. More critically, the emphasis on weight reduction that had enabled zero agility was incompatible with the armor protection and structural strength required for high-speed combat against heavily armed opponents. The design philosophy that had produced Japanese air superiority in 1941 was obsolete by 1943 standards. Strategic assessments concluded that Japanese air strategy required fundamental revision to address American technological superiority that could not be countered through existing aircraft and tactics. The concentration of remaining air strength in defensive operations would delay American advances but could not prevent eventual defeat unless Japanese industrial capacity could produce aircraft competitive with the Corsair and other advanced American fighters. The mathematical progression of attrition warfare favored American forces that could replace losses while maintaining technological advantages, creating an unsustainable situation for Japanese air power. The subsequent encounters between Corsairs and Japanese fighters confirmed the tactical superiority demonstrated during the initial engagement over Bougainville. American pilots quickly developed standard operating procedures that exploited the F4U speed and climb advantages, while avoiding engagement conditions that favored Japanese aircraft. The systematic destruction of Japanese air power proceeded through individual combats that produced favorable exchange rates while exhausting irreplaceable pilot resources. By the end of 1943, the balance of air power in the Solomons had shifted decisively in favor of American forces equipped with technologically superior aircraft. The broader implications of Corsair superiority extended to American industrial strategy that prioritized technological advancement over numerical production in certain categories. The decision to develop advanced fighters rather than simply increasing production of existing types reflected confidence in American engineering capabilities and willingness to accept development risks for technological advantages. This approach enabled American forces to maintain qualitative superiority while achieving numerical parity, creating multiplicative advantages that overcame initial Japanese strategic positions. The operational research conducted by American technical intelligence revealed the specific performance characteristics that enabled Corsair superiority over Japanese fighters. Speed advantages of roughly 50 to 75 miles per hour at combat altitudes provided tactical initiative that could not be overcome through superior piloting or tactics. Climb rate advantages of hundreds of feet per minute enabled vertical escape maneuvers that Japanese aircraft could not counter. These quantitative advantages translated directly into combat superiority that was measurable and repeatable across different engagement conditions. The logistical infrastructure supporting American fighter operations demonstrated industrial capabilities that Japanese planners had not adequately considered in strategic calculations. The ability to transport complete aircraft across specific distances while maintaining supply lines for fuel, ammunition, and replacement parts reflected organizational competence that enabled sustained operations far from industrial bases. Japanese logistics systems lacked comparable capabilities, constraining operational flexibility while creating vulnerabilities that American forces could exploit through sustained pressure. The tactical evolution of American fighter doctrine accelerated through combat experience that validated technological advantages while refining employment techniques. The development of coordinated attack patterns that maximized Corsair performance characteristics created standard procedures that could be taught to new pilots while maintaining effectiveness against experienced opponents. This systematic approach to tactical development enabled rapid dissemination of successful techniques while avoiding the individual heroics that had characterized earlier American fighter operations. Major Boyington's subsequent command of VMF 214, the famous Black Sheep Squadron, demonstrated the potential of Corsair capabilities when exploited by experienced pilots using appropriate tactics. The squadron's tally of over 90 confirmed victories during roughly 3 months of intensive combat represented the effectiveness of superior aircraft employed through coordinated tactics that maximized technological advantages. Individual pilot scores reflected the multiplicative effect of better aircraft and better tactics, creating success rates that exceeded historical norms for fighter operations. The industrial competition between American and Japanese aircraft development revealed fundamental differences in approach that determined ultimate outcomes. American programs emphasized performance improvements through technological advancement while maintaining production efficiency, creating aircraft that were both better and more numerous than Japanese equivalents. Japanese development focused on incremental improvements to existing designs while resource constraints limited production quantities, resulting in aircraft that were inferior in both quality and quantity to American counterparts. The strategic implications of American fighter superiority extended beyond air combat to enabling unrestricted bomber operations that systematically destroyed Japanese industrial and military capacity. The inability to contest American air superiority eliminated Japanese options for defending critical installations while exposing supply lines and naval forces to continuous attack. The cascade effects of air superiority created operational advantages that multiplied initial technological superiority into decisive strategic advantage. The human cost of Japanese tactical failure reflected the expenditure of irreplaceable pilot resources in futile attempts to counter American technological superiority through conventional tactics. Experienced pilots who had achieved victory against earlier American fighters were systematically eliminated while failing to achieve comparable results against Corsair-equipped units. The degradation of pilot quality compounded equipment disadvantages while preventing effective adaptation to changing combat conditions. The final assessment of Corsair impact on Pacific air warfare confirmed that technological superiority, when properly exploited through appropriate tactics and adequate numbers, created decisive advantages that could not be overcome through traditional military virtues. The systematic destruction of Japanese air power proceeded through individual engagements that demonstrated American capability to achieve tactical objectives while maintaining acceptable loss rates. The cumulative effect transformed initial American disadvantages into overwhelming superiority that determined strategic outcomes. The legacy of the F4U Corsair in Pacific combat extended beyond individual aircraft performance to validation of American industrial and military capabilities that had been questioned during the early phases of the war. The ability to design, produce, and employ technologically superior weapons systems demonstrated institutional competence that enabled victory through systematic application of superior resources. The Corsair's speed advantage over Japanese fighters became symbolic of broader American advantages that determined the outcome of the Pacific War. On February 14, 1943, when 12 F4U Corsairs first encountered Japanese fighters over Bougainville, the engagement marked more than a tactical victory for VMF-124. The systematic destruction of experienced Japanese pilots by American fighters that could outrun, outclimb, and outgun their opponents demonstrated that technological superiority, when properly applied, could overcome numerical disadvantages and tactical experience. Beyond the order of 50-mile-per-hour speed advantage that enabled Corsair pilots to control engagement timing while remaining beyond effective counterattack range, had shifted the balance of Pacific air power permanently in America's favor. The Zero that had dominated Pacific skies for 18 months had met its superior in an aircraft that combined devastating speed with the firepower and coordination to exploit that advantage systematically. For Japanese pilots, the encounter with America's bent wing fighter marked the beginning of the end for Japanese air superiority, as the Whistling Death proceeded to destroy more than 2,000 enemy aircraft while producing a generation of American aces who would carry the war to Japan's home islands.